So, a few months ago, I started learning some basic digital electronics and ended up building an 8-bit computer using this simulation software by Sebastian Leigh. This is all that the software comes with, just an AND gate and a NOT gate. I actually liked it this way because it allowed me to build everything from scratch, thus giving me a much more thorough understanding of how digital electronics work. From here, I built other logic gates and then constructed more complex components, like flip-flops, registers, and counters. I was using this textbook as a guide, called Digital Computer Electronics by Paul Malvino. This is where I obtained the schematics for constructing this computer. So, this here is a snapshot of the computer, and I am just going to compare and contrast it to the textbook schematic. At a glance, the two may not look so similar because I had to work with limited space here, so they might seem slightly different, but trust me, they have the same architecture. Here, we have the program counter. This is what sends the address of data to be fetched to the memory address register. The memory address register holds this address, and once it receives the appropriate command, it sends it to the random access memory. This memory here is a 16 by 8 RAM chip. For me, this was the most difficult component to simulate, but after a bit of tinkering, I managed to create a working version of it on this platform. The RAM is where you load your program, which is basically a set of instructions for the computer to follow. These are entered in binary form, which is called machine language. Next, we have the instruction register. This receives an 8-bit string from the RAM and splits it into 2 nibbles. The next component is the controller sequencer, which generates a 12-bit instruction string that controls all other components, telling them what to do and when to do it. We also have 2 registers here, the accumulator and the B register, which hold numerical data from memory. This data is accessible to the arithmetic and logic unit, which performs addition or subtraction on the numbers. These are the only mathematical operations that it can do. Lastly, we have an output register here, and this stores the result of the arithmetic operation and then displays it here in binary form. So, this is the basic structure of the computer. Now, each component here has several levels of intricacy because I had to build each one from the basic building blocks that I had constructed before that. This computer understands 5 basic instructions, called its instruction set. Now let's run a simple program to illustrate the computer in action. I will be using this program as an example. It simply adds 5 and 4. So the expected answer is 9, but it will be in binary form. Now I have loaded the program and I am going to start the computer. After a few seconds of blinking lights, you will see the result here. If enough people show interest, I would like to start a video series in the future that goes over all the intricate details of how this computer works and teaches you all digital electronics starting from scratch. That's it for this video. Thank you for watching.